Okay, so this is chapter 7. The whole chapter is over energy. The key words that are important, this is a concept map. If you've done a concept map before, you have keywords that are in the bubbles. Okay. Off of the main concept, we're going to branch out and talk about all the different aspects of what energy is. So one of the first things we talked about are forms of energy. And remember, big E stands for energy. You guys are allowed to answer questions. This is an active recording, those of you who are watching. Forms of energy that we talked about are what? Kinetic and potential can be part of all forms of energy. So what are the forms? Radiant is one. What's another? Yeah, gravitational would go with potential, so your gravitational potential energy. Nuclear. What's another one?
Sound.
Sound would fit where? And what kind of energy?
Radiant.
Not with radiant.
Waves.
Waves are the source of energy that sound makes by traveling through something, and it creates pressure. So that kind of would tie in with that. Okay. Sean.
Electrical.
Yes. Electrical.
Mechanical.
Yes. Mechanical. It's another one.
Chemical.
Chemical. Elastic. We just did that with the tennis balls. Another one where we could fit the sound in with light and all the other kind of sources of energy. In the book, they identify it as the electromagnetic spectrum. So these are forms of energy that they talk about. All these forms of energy can be converted into one form or another, right? So we have our law of conservation of energy. Which basically states energy cannot be created or it can only be transformed into another form. Okay. So we have energy transformations. And if you guys remember way back, there was a worksheet that you did that kind of covered this at the very beginning that we have not revisited. but it's one of those common things. If you talk about even in the tennis ball lab, you had to think about the other forms of energy that were there, because it's more than just potential to kinetic. There's other forms that it can change to. So if I have a lamp that I want to turn on, what is the transformations of the energy to get a lamp?
Mechanical.
Well, we have mechanical because you have to physically turn it on. What is another form of energy before we get to mechanical?
Chemical.
Chemical for what?
From like either the coal or the burn to be turned to electricity.
Okay, so if we have our coal that is turned into, so we can actually make this really long. The coal is, what happens to the coal?
Burn.
Burned, so it's turned into thermal. Then it's turned into mechanical, because it turns the turbine from the heat that heated up the water that created the steam to turn the turbine to turn to mechanical. Then it turns it into electrical. Then that electricity comes to the lamp and turns into radiant and thermal. And it all depends on what light bulb you use too. So you can get both. Does that make sense?
Did you even start off with chemical, because the chemical reactions that happen with the sun, then that turns into radiant and thermal?
Oh, we could take it back of how coal was formed and take it back to that process. So point being, because it goes all the way back to the what?
The sun.
Everything goes back to the sun. So all energy ultimately starts with the sun. Okay. So we know all of these forms of energy have the ability to be potential energy or kinetic energy. Now you can take this a step and we can talk about potential energy. You have GPE, which involves your gravity, which we all know is 9.8 meters per second squared. Potential energy is what? In an object.
The height of the object.
It depends on the height. Potential energy depends on height. Because an object sitting still at a certain height, and that's the thing, potential energy is an object that is not moving. It's the potential that it has to turn into usable energy. Because kinetic energy is energy of motion. So we know this deals with height because our equation for potential energy is PE, your potential energy, equals your mass times your gravity times your height. Now remember, what is mass and gravity together? Newtons. Okay. And then you have your height, which changes, so that's going to change the potential energy. Kinetic energy equation is half of your mass multiplied by your speed squared. Key thing is remember to square. Okay. So all this energy, when we solve for this, the unit for energy is what? Joules. abbreviated with a J. That's a lovely circle. Okay. The key thing with potential and kinetic energy is it transfers back and forth, as we saw in the tennis ball lab, correct? So when it transfers back and forth, we know what has happened. What has been done? Work. So in order to find work, we multiply the force times the distance. And we know if distance is 0, is there any work done? No. It doesn't move. You can move up here. So work is basically the transfer of energy. We have forms of energy and we have sources of energy. What do I mean by sources? Because we have to get chemical energy from somewhere. What is it? What is the source that the chemical energy comes from? And this comes from that activity that we did with the energy roundup with the green and yellow posters. So we have two types of sources. Renewable and non-renewable. And the key thing to remember is renewable does not mean reusable. Because when we looked at the transfer of energy, it's linear. It goes in one direction. You can't take this radiant and thermal heat here at the end of the lamp and take it back to coal. It's a linear pathway. Does that make sense?
Yeah.
Okay. What are our renewable sources? We have water, which is our hydropower. Solar. Wind. Water is our hydropower. There's 3 of the 5. There's 2 more. Geothermal. That's using the heat of the earth. And biomass. And that's taking the organic matter and burning it to get the heat. Okay. What are our non-renewable sources? Coal. Petroleum. Nuclear. And we will say uranium, because that is the main source that's used in the power plants.
Natural gas.
Natural gas. And one more. Propane. Can you see how it's it ties all together? All this bases off of energy. The big picture. Any questions? It is a lot of words, and that's why it seems like it's taken us forever to get through this chapter. Okay. So these are the key things to focus on.